I would say the most common mistake is probably just a misunderstanding of PPE, which is personal protective equipment, knowing when to wear gloves, when to wear safety glasses, when to wear a lab coat for the safety of the researcher. A couple of big categories, and all of this would be identified in really two major publications. One is the NIH guidelines for recombinant DNA research, and the other would be something called the BMBL, which is a publication by the CDC. It's biosafety in microbiological and biomedical laboratories, and they will refer to, again, PPE, transport of materials, disposal of materials. They pay very close attention to your use of sharps, and then of course anything dealing with pathogens or recombinant DNA has very specific requirements. That's an interesting question. In my opinion, I think it would be an intentional contamination, because you wouldn't necessarily know what the agent was or what the scope of that release was. In an unintentional, I'm assuming that is an accidental spill. You know what you're dealing with, you know where it was spilled, you know how much was spilled. I think I would choose the same one. I would say an intentional release is going to be more dangerous, because again, this may be something that was specifically engineered to be resistant to our vaccines, to be resistant to our antibiotics, and we wouldn't necessarily know that. High security, so again, we would be looking at the NIH guidelines, and they are very specific. Bacteria are classified according to risk groups. So a low risk would be something that does not cause human disease, something that if it did cause human disease, we have known treatments for that. Those would be lower risk. As you get into the high risk, high security, those are pathogens that cause human disease, particularly ones that we do not have antibiotics or vaccines against. From a scale-up perspective, there are going to be all kinds of experimental details that you will need to adjust. From a biosafety standpoint, obviously you have more material. So disposal is going to become a bigger issue. You're going to have to figure out how to get rid of, maybe liters worth of sample instead of milliliters worth of sample. And care in transport, care in training of personnel, so that they are familiar with procedures at this greater scale. Again, NIH guidelines will be very specific in terms of the type of organism from which that gene was taken, and what are the possible outcomes now of using that gene in another organism. And that could range everything from possible pathogenicity in the new organism to antibiotic resistance to potentially causing cancer in a recipient of that. So for a transgenic product, again, the same type of things. You want to be absolutely sure that this new organism is not going to cause disease in that human as a recipient. You would also want to consider all the way out to, is it possible that this product or this organism might result in cancer in that individual? Most academic institutions will have what's referred to as an intellectual property policy, and that will be negotiated between the institution and the investigator. The institution is providing the overhead for your project, so lab space, power, water, all of that. They have some right to that product, but that would all be spelled out in the IP policy. Typically, the next step there would be to bring in a patent attorney to do the background research and look into the possible usage of that product, at which point you would then file the patent application, and it can take quite a while before that patent application is actually reviewed and you get a final answer as to whether or not this is going to receive